Welcome to this video on the foundations of AI/ML governance. We will cover building robust frameworks for responsible artificial intelligence and machine learning deployment in modern enterprises. This program is brought to you by the Series of Thoughts team as part of the AI/ML governance series. Technovative AI, the company that helps you leverage cutting-edge AI technology to streamline operations, boost productivity, and accelerate growth. Chapter 1 focuses on understanding AI governance. This framework of policies, processes, and controls ensures AI/ML systems align with organizational values, regulations, and ethical standards. The governance hierarchy has 3 interconnected layers. Data governance is the foundation. AI governance sits in the middle, providing strategic oversight. Model governance is the most granular layer, managing the model's technical lifecycle. Traditional software development lifecycles fail for machine learning due to data dependency, non-determinism, and model drift. These unique challenges require continuous monitoring and specialized governance. Effective AI governance connects strategy, risk, and operations. It translates high-level principles into actionable policies and establishes clear workflows for deployment, ensuring accountability and consistency. Chapter 2 introduces the AI governance operating model. A well-designed model defines roles, responsibilities, and decision structures, ensuring coordination between technical teams and oversight functions. Board and executive oversight provide strategic direction and ultimate accountability. Leaders set the risk appetite, approve major policies, and regularly review AI portfolio performance and risk exposure. The AI steering committee is cross-functional, including information technology, legal and compliance, security and privacy, and business stakeholders. This composition ensures a balanced view of technical, legal, risk, and business needs. The steering committee's functions include reviewing and approving AI use cases, monitoring portfolio performance, resolving cross-functional issues, and continuously evolving governance policies. The RACI model clarifies decision rights and accountability. It defines who is responsible for executing the work, accountable for the outcome, consulted for input, and informed of the decision, preventing bottlenecks. This RACI example shows how responsibilities for model deployment approval are distributed. The business owner typically maintains ultimate accountability for the final deployment decision, consulting other critical functions. Chapter 3 examines the governance lifecycle. AI governance operates across a comprehensive lifecycle from concept to retirement, ensuring consistent oversight and controls at every stage, tailored to risk level. The 7-stage AI lifecycle includes ideation, data readiness, model development, and validation. Formal gates ensure readiness before progression, with monitoring insights feeding back into the cycle. Stage 1, ideation, focuses on concept development and evaluation. Governance ensures strategic alignment and ethical considerations. The concept approval gate requires clear business value and an acceptable risk profile. Stage 2, data readiness, ensures data is available, quality checked, and appropriate. Controls include bias testing and privacy analysis. Approval confirms data is sufficient and compliant before training begins. Stage 3, model development, emphasizes documentation and reproducibility across algorithm selection, feature engineering, model training, and initial testing. Technical rigor enables independent validation later. Stage 4, validation, provides independent assessment of performance, fairness, security, and compliance. This gate is critical for ensuring the model is fit for its intended purpose before deployment. Validation includes key controls like performance testing, fairness assessment, explainability analysis, security review, and compliance checks. These ensure comprehensive evaluation against all requirements. Stage 5, deployment, transitions validated models to production. Key controls ensure monitoring system activation and rollback procedures are in place. The approval gate requires sign-off from all critical stakeholders. Deployment strategies such as pilot, phased rollout, or shadow mode are used to mitigate risk. Shadow mode, for example, validates predictions against outcomes before full activation. Stage 6, monitoring, is continuous performance oversight. It detects model drift, data quality issues, and fairness degradation in production, triggering alerts and informing governance decisions. Key areas to monitor include model performance, data quality, fairness metrics across groups, and the actual business impact achieved. Setting alert thresholds is crucial for timely intervention. Monitoring triggers governance actions. Alerts lead to defined response protocols. escalation paths, and remediation plans, ensuring that issues like performance degradation or fairness concerns are promptly addressed. Stage 7, retirement, manages the end of a model's useful life. Rigorous planning ensures continuity and compliance. The approval gate confirms replacement capabilities and proper data archiving are complete. Retirement factors include business discontinuation, technology obsolescence, performance decline, regulatory changes, or the availability of a superior replacement. These justify the transition costs. Governance controls vary across the lifecycle. For example, ideation focuses on strategic alignment and is approved by the steering committee, while data readiness is managed by the data governance lead, focusing on privacy and quality. A risk-based governance approach tailors controls to the risk level. High-risk models require extensive documentation and executive approval, while low-risk applications use streamlined, delegated processes. Comprehensive documentation is essential for governance and compliance. Key documents include the model card, data documentation, technical specifications, validation results, and operational procedures. Measuring governance effectiveness requires clear metrics. These include process metrics like documentation quality and audit findings, and outcome metrics such as business value delivery and risk incidents. Key governance performance indicators provide measurable insight. Examples include the gate completion rate, average days to approval, active models in production, and realized value delivered. Common governance challenges include balancing bureaucracy with agility, addressing a lack of expertise, and managing tool limitations. Proactive strategies are needed to mitigate these pitfalls. AI governance maturity evolves through stages: initial, developing, established, and advanced. Organizations should prioritize improvements to move from inconsistent processes to an optimized, innovation-enabling state. Practical next steps include assessing the current state, establishing the governance structure, developing core policies, implementing lifecycle gates, building monitoring capabilities, and measuring and improving continuously. Key takeaways emphasize that governance is essential for responsible innovation and requires a lifecycle approach. Effective implementation relies on cross-functional collaboration, risk-based controls, and continuous monitoring. AI governance is the foundation for responsible AI futures. By implementing robust, lifecycle-based frameworks, organizations can realize the transformative potential of AI while maintaining trust and compliance.